Hello, everyone, and welcome for today's Teach Back for Information Architecture. We will be taking an in-depth look into an Amazon services like S3, SQS, Lambda, and how they can be brought together into a simple yet very effective architecture. My name is Gagan Preet Singh, and I'll be your guide through this comprehensive walkthrough. Let's quickly go over the AWS services we'll be focusing on today. S3 is an scalable, high speed, web based cloud storage service. SQS is a fully managed queuing service that aids in decoupling and scaling microservices, distributed system, and serverless application. Lambda is a compute service that let you run the code without provisioning or managing server and scaling automatically as it's needed. Amazon S3 storage service offer an industrial leading scalability, data availability, security, and performance. It's designed to store, retrieve the amount of data from anywhere on the web. The key feature includes extreme high durability, comprehensive security and compliance capability, and querying in place functionality for the big data analytics. The common use case include backup and restore content distribution, data and the big data analytics. Amazon SQS or Simple Queuing Service is fully managed message queuing service that decouple microservices, distributed system, and serverless application. It allows for the transmission and retention of the large number of the message to be produced asynchronously. The key feature includes atomic scaling, at least one message delivery guarantee, and unlimited concurrent transitions. SQS common use case is used to buffer the request, handle asynchronous tasks, and decouple applications. AWS Lambda is serverless compute service that lets you run an application without managing the underlying infrastructure. It executes your code only when required and automatically scales to and handle the traffic pattern of your application. With the Lambda operation task like handling operation system, patching, and scaling are taken care of it by itself. It's commonly used in real time file processing, running HTTP codes and requests using AWS API gateways, processing streaming data, storing in Kinesis, and creating a serverless backend. Now let's talk about simple architecture, user to S3. In our simple architecture, user interacts to an Amazon S3 primarily through an API call. For example, a user might upload a file to S3 using a put object API call. When a new object is added to an S3 bucket, it can trigger an event. These events can be configured to send a notification of the object created to the other AWS services, such as Lambda or Amazon SQS. Now, let's talk about S3 to SQS. When a new object is added to an S3 bucket, and send an event notification to SQS. This notification is then queued in SQS as a message. The SQS maintain and track the messages until it's been consumed and processed by another service such as AWS Lambda. This allows for the asynchronous processing of the message, ensuring no data is lost even if the processing service is temporarily unavailable. Now, let's talk about SQS to Lambda. An available message in the SQS queue can trigger an AWS Lambda function. The Lambda service poll the queue and invoke your function synchronously with an event that contains queue message. Once triggered, the Lambda function can process the message. This process is typically asynchronous, greatly improving the performance of the application by allowing them to continue processing the request while long running the task and handle in the background. So now let us summarize the architecture. This architecture involves the user interacting with an Amazon S3, which triggers an event when a new object is added. This event sends a message to Amazon SQS, which stays in the queue until it's been consumed by the AWS Lambda function. The Lambda function then process the message. This architecture is commonly used in the application that needs a process user uploads from some form of data transformation or run an analytical on a new added data. It offers an scalability, reliability, cost efficient, and improved performance. Now, let me walk through you all to a demonstration. So, I'll be setting up the S3 bucket, creating an SQS queue, and then creating a Lambda function. Then we'll be configuring S3 and sending an event notification to SQS, and the SQS to trigger the Lambda function. Finally, we'll put this architecture to the test by uploading a few files on the S3 bucket and observe how the trigger triggers the Lambda function through an SQS, and also we'll see the CloudWatch logs to see if the Lambda function is able to get the all the queues one by one. So here is the architecture that we'll be making out from the scratch, and we will be building up this architecture step by step. I have already written all these steps here. I'll be providing this all the steps so that you guys can also try doing it once by yourself and understand like how this simple trio architecture works. So let's quickly jump on the AWS and let's start with building this particular architecture. So the first thing we'll need to do would be the creating an SQS queue. I have given the name here, so let's copy the name, which is teach back demo. Let's go on the queue. I don't see any queue which is being created here right now, so let's quickly create a queue. We'll be coming here, we'll be keeping everything as it is right now, and just giving the name here, and all the other configurations, let it be remain as default as it is. It is a very best practice that you should always tag your services that you are creating, so it becomes very good practice that you can track which services are being consumed, and like for production or any development environment you can do that. For example, you can put a project name here, and then you can give teach back demo. You can name it as this, and then we can create a queue. So the queue is being created here. If we just refresh it, we can see the queue has been created. We can go back to the queue, and we can see there are 0 available messages and 0 in flight. So now going to the S3 bucket, going back to the architecture, the next step is to create an S3 bucket. So we'll be creating an main directory, which is teachback demo bucket, and inside also we'll be creating a subdirectory. So what happens in real world scenario, there would not be only one directory, there would be a multiple directories inside the directory, and that would be sorry, and from there the queue would be configured. So going here, we will be creating a bucket, uh, giving a name to it, and we'll be keeping everything as it is. So also keep in mind that we are blocking the public access. We have blocked all the public access, so we might need to configure the policy so that the event can be generated and SQS can process that event. Going down, we'll be creating a bucket here, and once the bucket has been created, we'll create a sub bucket inside it. Now going back to the architecture, we do have teach back demo 1. We'll be creating this same as it is, and now we can see we have the bucket named teach back demo bucket 1, and we have teach back demo 1. Now we have created the SQS and we have also created the S3. Now we need to update the policy of SQS so that SQS can take the notifications, or the event which has been generated by S3 can be accepted by SQS. So going back to the SQS, we'll be clicking on the edit button. Going down, we can see the policy. So my suggestion would be, like, the simplest way to create a new policy is to use this in-house service for AWS for policy generator. Just click on it, you will see the policy selected in SQS. Principal for now will be keeping as everything, and the action would be for all. About the ARN, we'll be going back, and this is our resource ARN that we'll be copying from here, and we'll be pasting it. Now the condition we need to add is for the resource ARN, which is your S3 bucket. So going on the S3 bucket, going on the properties, we will get an Amazon ARN here for the S3 bucket that we just created here. Going back to the policy and pasting the value, and we will add the condition and add the statement. Once the statement has been added, we'll generate the policy. So you will see the principal is everything, and we have the source ARN, then source for the our teach back demo for the SQS, and this is for the S3 bucket. We can copy paste this. I have also given the same thing here. I have attached, or you can copy it from here as well, and go to the SQS, and you can simply replace it from here. And once that's been done, you can just save it. Here now we have created the SQS, and now we have to create an event notification. Going on to the, we can close this policy generator. Going to the bucket, we will going to the properties, and coming down, we can see the event notification, which is here. So we'll be creating a new event notification. We can name it as teach back event, which is here. So you can give this is a very common practice where you can give the inside bucket name as well, and we can also give a suffix for it. Like, for example, we can give only .json files or .csv files, only that notifications or that particular events would be generated and sent to SQS. For now, we'll be keeping all the bucket that been recently, all the object that creates an event here, and coming down, everything would be the same, but we'll be selecting an SQS queue here, and the queue that we have created, teach back demo, and we will save the changes. Okay, I think there is a problem for it. Let me see, unable to destination configuration. Let me quickly go and see the thing here. So we do have the name here, and that looks pretty much good. We'll edit and see the policy as well. Policy looks good here. So the problem is with the policy. We do have with the name of teach back demo here, but our policy, which is q, is different, so we might need to change the policy here. Coming back here, and so this is this happens when the queue, the ARNs and everything's are not given properly, and we can give the name as this, and we can save it again. So going back to it, and we have teach back demo. It should work now, and it worked. Now we have our event being generated as here. So I might need to update the policy here as well for you guys. So I demo, there you go. Now we have created an event. Now let's go back to the queue and see if we have any kind of message. See, we got one message which is available here, and why it's here? It shouldn't be here because we never uploaded any kind of CSV file or JSON file or anything on the object, but why it's here? So what actually happens is whenever you configure an event notification to an SQS, AWS S3 sends a test notification to your SQS, and we can also go inside SQS and we can check what notification was there. We can go on the send and receive messages. Then when we can poll off the message, we can see one of the messages there, and then we can see S3 event test event is there. So it's the test event which is sent by your Amazon S3. Done. And we can stop the pool here. It goes back. Now let's on the step number 5, that we need to create a function here. Let's create a lambda function. For now we don't have any lambda function. We'll be creating a new lambda. We'll be selecting Python, and every other thing would be remain as same. So here the lambda has been created, and we can see the code here. Okay, so this is the code, and we can refresh the page once. So we see a code here. So we'll be replacing this code by our own code, and I'll be explaining what this code actually does. Going back to the thing, and we can deploy it. So what this code actually does is we are importing JSON library here, and then we have a try and exception here for any error comes, or we any error occurs, so we can print the exception for debugging purposes. So we are not doing much here. We are only loading the event here, and we printing the event, plus also we are checking if the bucket event is been captured as expected. So it prints the objective key from the S3 event and the name of the uploaded file as well. So going back to the steps, we need to configure the AWS Lambda's role so that it can receive the messages from the SQS. We'll go on the configurations, and we do see a role here. We'll click on the role, it will redirect to the IAM services, and here we need to attach a permission. We need to select SQS here and a full service and add permission. So it's been added here. We can close this tab and then go back to the architecture. We see that now we have to upload few files on the S3 bucket. Let's go and quickly upload file on the bucket. So we'll be uploading a file here as well, and inside this teach back demo 1, so that because we have allowed any object that created in the or uploaded in the bucket will be sent as an notification or as an event to an SQS. So we'll be uploading a file here. Let's add a file. Let's go to this, open, and then we'll upload it. This has been uploaded, and we'll close it. Now we'll also go to this particular demo and we'll upload it, the other file as well. Suppose get one, we get m4 data CSV. Let's upload this. There you go. Now we have two files on it, and let's see if events were being generated or not. There you go. We have 3 events being generated. So one was the test event and 2 events which we uploaded the file here. Like one was the m data and the other was the taxi profiling data. So we can also see the queues that like I showed you earlier as well. For the polling messages, we can see we have 3 queues here. I can check. This is the test event. The other one was the event generated and what was the time of it, and also goes with the other one with the same thing. Now we can stop pulling it. Now going back to the Lambda function, we will be adding a trigger here. So the source of our trigger would be SQS, and we'll be keeping the batch size to the minimal one, windows to be minimal one, concurrency is optional. Then we'll be creating the trigger maximum. Oh, we never added the, so here you need to add the SQS. Now add. So once this been added, see the status is creating. So once this has been created, the 3 notification that we saw in the SQS, that should get vanished. So we have 3 here. See, now we have 0 because all the messages are being consuming by the Lambda function here. So we have 0 in our messages and 0 in our flight as well. You can refresh this and it's been enabled. Let's go to the monitor and we can see some CloudWatch logs should be generated here. So we can see 2 logs have been generated. So click one of the log here, and we can see the start time and the end time as well. So we got the first thing was the test event that we talked about, which um, the S3 sends. So we got one other thing, and the other object that we uploaded was in teachback demo m4 data.csv. We got the second one here, and there should be one more event that should be generated. The, let's go back to log as well and try to refresh it again and go back it again. So here's the one, here's the messages here, and we can also copy the whole message here and go on the JSON formatter and try to underscore here. Yeah, and process. So we come here, and here we can see the records and the messages. So the event was been generated, the event version, the event source, and the S3 here. So we are getting the events from the S3 now. So architecture has been completed. So the user has been uploaded the files, two files, the event generated, and the event sends the notification to SQS, and SQS triggers the Lambda from where they get the file and process it. And we have seen the logs as well in CloudWatch that the thing we needed to print is been printed here, like teach back demo and m3 data, which is here. So let's go back to the slides and continue there. So we just saw the demonstration how we configured Amazon S3 SQS Lambda and their interaction between them. So to just recap our session, we have explored Amazon S3 SQS Lambda and their interaction and their role in the simple but very effective architecture. Understanding these AWS services and how they interact in is very crucial for designing an effective cloud architecture. I really do encourage all of you to experiment with these services and try to build an architecture out of it. If there is any doubt, any discussions needs to be done with me, I'm really happy to help. You can ask me directly, or you can DM me, or post in the below comments. Thank you so much for your time. Hope the session was good.